Number 16, which function described below is quadratic? So remember, quadratics are basically parabolas, and they have an x squared term. So if I look at my answer choices, in choice 1 that says y equals 2x, that cannot be correct because there is no exponent on my x, and that is an example of a linear function because it's in the form y equals mx plus b. If I look at choice 2, let's look at the change in our y values to go from a 3 to a 2. I subtract 1, 2 to 1, I subtract 1, 1 to 0, I subtract 1, and 0 to negative 1, I subtract 1. That is also linear because it has a constant slope. My x values are going up by 1. And then if I look at choice 3, that one could be quadratic. I go down by 5, I go down by 3, I go down by 1, and then I go up by 1. So I don't have that constant rate of change. Now, if I look at choice 4, that's an absolute value graph, because if you remember that what we did earlier, absolute values are V-shaped. So it can't be choice 4 either. Now, the technical way of doing this also is to look at your second differences. To go from a -5 to a -3, that's +2. -3 to -1, that's +2. And then -1 to 1, that's a +2. So that's another reason why this is quadratic. And also, you could sort of see that my values start repeating themselves. I go from 8 to 3, 3 to 0, 0 to -1, and then I come back to 0, which means it is following that U-shaped curve.